Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that solve the following differential equation. Solve the following differential equation using the method of variation of parameters. So this is the differential equation. Solution. Now, this is the differential equation. Before we use the method of variation of parameters, we have to solve this differential equation by setting the square y over the x squared plus the y over the x equals to 0. So now we will substitute the y over the x as m, so this becomes m squared plus m is equal to 0. Then when we factorize this, it becomes m plus 1 is equal to 0. So this becomes m is equal to 0 or m plus 1 is equal to 0. That's m is equal to 0 or m is equal to negative 1. So now, since our roots are real and distinct, we are going to, the general solution will be y is equal to a exponential 0x plus b exponential negative x. According to the method of variation of parameters, we are going to substitute this exponential 0x and exponential negative x as what? We will say u1x will be equal to this exponential 0x, which is equal to 1, and u2x is equal to exponential negative x. And we will find their derivatives. So this becomes u1 prime x. The derivative of 1 is 0. And this u2 prime x. The derivative of this is negative exponential negative x. Now we are going to replace these constants a and b with v1x and v2x respectively. So now this equation becomes y is equal to v1x exponential 0x plus v2x exponential negative x. So we have replaced a and b with v1x and v2x respectively. Now, in variation of parameters, there are two simultaneous equations we usually solve. So those equations, I'll write those equations down. This equation, the general form of this equation is this. A the square y over the x squared plus b dy over the x plus cy is equal to f of x. This is the general form of this equation. So now, from this, if you relate these two equations, you know that fx is equal to x, because this is the only term on the right hand side. So they are both equal, and this term can be equated to this. So now the two equations that we solve when using method of variation of parameters are this. This is the first one. It will be v1 prime x u1x plus v2 prime x u2x is equal to 0. So this is the first equation. I will say we solve in variation of parameter. Then the second one is what? Is a v1 prime x u1 prime x plus a again v2 prime x u2 prime x is equal to f of x. So this is the second equation we solve. So I'll call it II. So these are the two equations So these are the two equations we use. These two equations are constant. These two equations are always used in method of variation of parameters. So you need to note down and memorize these two equations because you are going to use them in solving all, because you are going to use them when you are solving using method of variation of parameters. You cannot avoid these two equations. So we can substitute into these two equations now. You know that here is A and A. From the general form of this equation, A is the coefficient of the square y over the x square, and here is 1. So there is 1, and f of x now is x. So f of x here is x, f of x here is x. So you get this f of x and A by comparing this equation with this. So now we'll substitute this. Let me write it here. So this is, in these two equations, our objective is to solve for v1 prime and v2 prime. Then after we get v1 prime and v2 prime, we can integrate them to get v1 and v2. So that is our objective. So let's substitute. This is v1 prime. Then what is u1x? This is, it is 1. So 1 times this is this, plus v2 prime x. What is u2x? u2x is exponential minus x. This is equals to 0. So this is our equation A. Then let's substitute in the second equation. A is 1, f of x is x. So this becomes what? u1 prime x. Then u prime u1 is what? u1 prime, then u1 prime is what? Is 0. So here will be 0. Plus this A is 1, v2 prime. Then u2 prime is what? Is negative exponential minus x is equals to x. F of x is x. So now 0 times this is 0. So here is 0. Negative times plus negative. Negative v2 prime exponential minus x is equals to x. So this is our equation B. So now let's solve A and B. So now let's solve A and B. Solving A and B using Cramer's rule. Solving A and B using Cramer's rule. So we'll solve A and B using Cramer's rule. So it becomes, so we'll take the terms. So we'll take the coefficients. Here will be 0, here is also, here will be 1, here will be 1, here will be 0. So it will be 1 and 0. Then here is what? Here is exponential minus x and negative exponential minus x. Then multiplied by our variables, which is v1 prime of x and v2 prime of x. Is equal to what? 0 and x. You know, Cramer's rule is like this: ax is equals to b. So this is a, this is b. No, this is a, this is x, but in this case is v. Since we are not finding x but v, then here is b. So a is 1, 0 exponential minus x and negative exponential minus x. So now we will find the determinant of this, which is 1 times, it is this term, the product of this term minus the product of this term. So it is 1 times time 1 times negative exponential minus x, which is negative exponential minus x. Minus 0, this is 0. So then a1 will replace the first column with this, so it will be 0 x, then exponential minus x, negative exponential minus x. So the determinant is what? This, which is 0 minus this, so it will be negative x exponential minus x. Then the last one, a2, is 1 0, then 0 and x. This one. So then this is 1 times x is x minus 0 times 0, which is x. So these are all the determinants. So we can now find v1 x prime, which is going to be this determinant over the determinant. So which is negative x exponential minus x over negative exponential minus x. So this minus and minus will cancel. This exponential and exponential will cancel. It will be what? X. This will give us x. And the second one is what? v2 prime x, which is equals to a2 over a. a2 is what? X over negative exponential minus x. So this is what? This will be negative. This exponential minus x will come up here and become exponential x. So it will be negative x exponential x. So now we have found the value for v1 prime and v2 prime x. So now these are the values. So to find v1 prime x and v2 prime x, we will find the integral of both sides. If you find the integral of v1 prime x, it will give us v1x. And if we find the integral of v2 prime x, give us v2x. So now we'll just take the integral of both sides here. So integral of here is what is v1x, then the integral of x dx. Here also be integral of v1 prime x dx, but the answer we already know that the answer is v1x, so there's no need to write it here. So the integral of x is what? Is x squared over 2 plus c. But since there's 1 here, we'll just say plus c1. Then the second one, v2x is equals to the integral of what? Negative x ex dx. So you know this one we have to use integral by parts to solve it. The product of x and exponential x. So we are going to use integration by parts. Let's integrate it. So now to find the integral of this, we can factor the negative to be negative integral of x exponential x dx. So now you know that when using integration by parts, x has a higher precedence than exponential x. So we're going to say u is equals to x and the v is equals to what? Exponential x dx. So now we'll differentiate this. So du is equals to 1 dx. Then we'll find the integral of both sides. V is equals to what? Exponential x. In this one, du over dx is equals to 1. So I cross multiplied, so I got this. This one will integrate both sides. Integral of exponential x is exponential x. So now the integral of this x exponential x dx is what? Is uv, which is x exponential x minus integral of v du, which is this times this. So it's ex dx. So now this becomes x exponential x minus exponential x plus c. So this is the integral. And due to there's minus, so before we even put the c, we'll put the minus. Before we put this c, we'll put this minus. So when we put the minus, it becomes negative times these two is what is exponential x minus x exponential x plus c. So this is it. This c is added after you finish all the forms of integration. So I added it here. So actually you are supposed to, after you put it, since there's a negative, if there was no negative, this would have been the answer. But since there's a negative, you have to open this bracket with it before you put the c. So this is the answer. So we'll substitute this back in the equation. So the integral of this is what? Is exponential x minus x exponential x plus c, or in this case is c2. So now we can factorize this. This is also the same thing as exponential x 1 minus x plus c2. So now we are going to substitute v1x and v2x back into the original equation. So now we are going to substitute v1x and v2x back into this equation. Back into this equation. This is the equation we are going to substitute v1x and v2x to get the solution of this. So we are going to substitute v1x and v2x into this equation. So let's do that. So now here is the equation. We are going to substitute v1x and v2x into it. So it will be, here is v1x. Here is v1x is x squared over 2 plus c1. So here will be y is equals to x squared over 2 plus c1 exponential 0x. Then v2x is what? Is exponential x 1 minus x plus c2 plus exponential x 1 minus x plus c2. So this is it. So now you can further simplify. This equation. So this exponential 0x is 1. So y will be equal to what? X squared over 2 plus c1. Then here is 1. Then plus this one, you can open the bracket with exponential negative x. It will become this exponential negative x times exponential x is what? It will become exponential x minus x, which is exponential 0, which is 1. So this will be what? 1 minus x. Then exponential negative x times c2 is what? Is c2 exponential negative x. So we have successfully solved the given equation by using the method of variation of parameters, and this is the final solution. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.